Guys, so I'm going to attempt to teach you the squeeze theorem on video, and then if there's questions, we'll meet for that. Now, if you haven't gone over those first two Delta Math assignments for limits, try to do those first, just to get your mind working on limits again. I mean, I guess it's not imperative, but it's a good review, and I think that you'll go, oh, limits aren't as bad as I thought they were. You know, back when we started. They're very tough when you start. Okay, so the squeeze theorem. This is something it wasn't super hard. It's just, I think our minds are overwhelmed at the time that we're learning limits, so that's why we didn't do them all. Okay, so here on Desmos, if you have Desmos or access to it on your computer, go ahead and put in that graph right there. Y equals the sine of 1 over x. And then we're going to look at finding the limit as x approaches 0 of this function. Okay, so if you don't want to put it in Desmos, don't worry, I got you covered. Okay, so here's the function. And one thing I do want you to notice, let me see if I can do this well, about this function is notice that what's happening here is it's oscillating. And we talked about graphs that oscillate, but we didn't really work with any at the beginning. And we said, okay, if they're oscillating, there's really no limit. So as I'm looking as x comes from the left, that would be the left, and as x comes from the right, where is this graph headed to? It just seems to be going between 1 and -1. Okay, and even if I kind of like zoom in, notice that it's really oscillating a lot. Okay, I'm not going to be able to find the limit of that. So it's oscillating, no good. Okay, now let's look at what happens if I put an x in front of that. Okay, so I'm putting an x in front of that. So I have x sine of 1 over x. Okay. And now let's look at what's happening. Okay. If I go in, I can see that I'm bounded. Okay, so now I can see that it's bounded between two lines, and I can see what's happening, that it's going to go towards 0 right there. Okay, so here, this is kind of the squeeze theorem in a nutshell. That if you have some crazy looking function that is, you know, it's oscillating all over the place, back and forth, but you can squeeze it between two other functions that you know the limit of, then you can find the limit of the difficult function. Okay, so now let's look at what we're going to do here. Straight up. Okay, so the squeeze theorem, we're going to say that if we graphed this, that we ended up getting some graph that, you know, oscillated back and forth, and we're going to say that this is kind of like a big blur, and that it oscillates, but hopefully spelling that correctly, and that there's no limit. That was one of our things from the very beginning of the year. Okay, so now we saw that if we put an x in front of it, what ended up happening is we kind of got these lines like this, and then it oscillated, and we were able to see that we could get that to come to a point. Okay, so it's squeezed between two lines. Okay, so let's look at what does the squeeze theorem say. Okay, so basically it says, okay, let's say that you have some function, and that this function can be squeezed between two other functions. Okay, so I'm just going to make these two functions here. I'm going to call this one f of x, and I'm going to call this one g of x. And then I'm going to have some crazy function in the middle. And I'm going to call that one h of x. Okay, and imagine these actually coming to an actual point right there. And that this is some value. Who knows? 1, 2, 3, who knows what it is. Okay, so the squeeze theorem says that if the limit as x approaches a of g of x is equal to some number L, and the limit as x approaches a of f of x is also equal to some number L, then the limit as x approaches a of h of x has to also equal L. Okay, so it's not really complicated, and we're really only able to do very introductory level of the squeeze theorem. It would be something that you would definitely use in a higher level math, but I want you guys to get the basics. Okay, so how do you know, like, when would you use this? And basically you want to think about it that the squeeze theorem is good for limits that are hard to find. Okay, so I'm just going to start with some really basic examples and of what I want you to know, like, about the squeeze theorem. Okay, so let's say I have some function here, g of x, and it's equal to 5x plus 2. And I have a function f of x, and it's equal to x squared plus 8. And that I tell you that g of x is less than or equal to h of x, and h of x is less than or equal to f of x. And I want you to find the limit as x approaches 2 of h of x. Now, we don't even know h of x, and we got to find this limit. Okay, so I'm just going to use this right here. G of x is 5x plus 2. And we said that's less than or equal to h of x, which is less than or equal to x squared plus 8. Okay, so we're just putting in what we know. Okay, now what I can do is I can take the limit of each of these pieces. So I'm going to say the limit as x approaches 2 is less than or equal to the limit as x approaches 2, which is less than or equal Okay, so hopefully if you reviewed your limits, that we could always try direct substitution. And we can try direct substitution. I know this is continuous. I've got a parabola. It can work. So that's going to be 12 is less than or equal to the limit as x approaches 2 of h of x and 4 plus 8. Okay, well, if they're both equal to 12 at that point, and this value is in between them, then I'm going to say thus, by the squeeze theorem. Okay, so we have to name it. The limit as x approaches 2 of h of x is equal to 12. Okay, so that's all I need you to be able to do is basically this thing right here. Okay, so that would be a really basic one. Like, I just gave you two functions. I told you that it was in between, but you are going to have to step it up just a little tiny bit. Okay, so let's look at something that we could do without the squeeze theorem, but let's see how the squeeze theorem works. And basically, when you're going to be using the squeeze theorem is either, I'm going to give you something like 2 equations, and basically you're just showing me that you know how to set it up, that you know how to do that, okay? Or you're going to notice it's going to be a trig function. Okay, so let's say that we have, as an example, that you have to find the limit as x approaches 0 of x times the sine of x. And we're going to assume that x is greater than or equal to 0. Okay, so this one's not going to be, we could do this in a different way, an easier way, but I just want you to think about the basics here. That the sine function, okay, remember that it just goes up and down, up and down. It's always between 1 and -1. That's the key. Cosine does the same thing. Okay, so, and remember, we call that the amplitude. The amplitude is the height. Okay, so if you're dealing with a sine function, the amplitude will always be 1. And so you know for sure that the sine always has to be between -1 and 1. Okay, so let's use that fact. So I'm going to say -1 is less than or equal to the sine of x, and the sine of x is less than or equal to 1. Okay, but this wanted me to find the limit if I put an x in there. All right, let's just multiply every single thing by x. That's -x is less than or equal to x times the sine of x. Oops, 1 times x is x. Okay, well, let's go ahead and add in our limit. So the limit as x approaches 0 of -x is less than or equal to the limit as x approaches 0 of x times the sine of x, which is less than or equal to the limit as x approaches 0 of x. Well, if I just do direct substitution right there, I'm going to get 0. Okay, so you can see that this is going to be just really repetitive. Oops, gosh. And they're all going to look kind of the same way. Okay, therefore, by the squeeze theorem. Some people call it the sandwich theorem. And people always said, oh, there'll never be one of these on the AP exam. Either last year or the year before. There was one on the, it wasn't last year, it was the year before. There was one on the AP exam. Okay, so it's real simple. Okay, so just kind of, you're just doing some algebra here. Okay, so the only difference is going to be, let's look at when we have a 1 over x. Okay, so I'm going to probably cut this one off right now because YouTube doesn't like me to do more than 15 minutes. So there'll be a part 2.